In this video, we're going to perform examples of a hypothesis test for a claim about a single proportion. For our first example, it says a recent survey in the New York Times Almanac indicated that 48.8% of families own stock. A broker wanted to determine if this survey could be valid. They surveyed a random sample of 250 families and found that 142 owned some type of stock. At the 0.05 significance level, can the survey be considered to be accurate? So I see that they've given me a significance level, which is a really good clue that I'm doing a hypothesis test or a significance test. They've made a claim about the proportion of families that own stock, and they've told us that that claimed proportion is 48.8%. We're told that they survey a random sample of 250 families and found that 142 owned stock. So let's go ahead and start by organizing our information. We're testing a claim about a percentage or proportion. So my parameter is P, and that equals the proportion of families that own stock. We're given that our claimed proportion is 0.488. Remember that we do math with proportions when they're in decimal form. I'm told my sample size n is 250, and the number of successes x is 142. I'm also given an alpha of 0.05. Before I write my hypotheses, since I am doing claims about a proportion, I should at this stage check that I can actually use a sampling distribution that's approximately normal to perform this test. And that involves the same check that we used for proportions when we did confidence intervals. You'll remember from last week, if we're working with proportions, in order to use a normally distributed sampling distribution, we needed to check that n times p was greater than or equal to 5, and n times q was greater than or equal to 5. So I would want to do that here. I know n is 250, and I know my p is 0.488. And I can see that that's 122, so the complement, 250 times whatever 1 minus 0.488 is also bigger than 5, much bigger. So we clear that hurdle nicely. You may assume for problems in the book and problems on your test that that condition has been met, but as a practicing statistician, that is an important first step before we perform these types of tests on proportions. Once we've performed the check, we go about our hypothesis testing. So we write our null and alternative hypotheses, claims about a proportion, null statement's always equality. We're claiming that it equals 48.8% or 488. And they ask, can the survey be considered accurate? Nowhere in this wording do they mention a key phrase that indicates less than or greater than. So we're assuming equal to is the claim, and we know that the default, when we're not given anything otherwise, is not equal for the alternative. So we want to know if the proportion is 0.488 or different from 0.488. to do this, we're performing a one proportion z-test. And to do that, we're going to go ahead and draw our standard normal curve. And then we're going to go ahead and use our calculator to find our test statistic and our p-value. So on our calculator, stat tests, I want one prop z-test. That's option 5. And one prop z-test asks us for our claim proportion. It asks us for sample successes, sample size, and then what our alternative looks like. So our p-naught is 0.488, successes is 142, sample size is 250, and we're looking at a not equal to. So our calculator is giving us a test statistic of 2.53, rounded to 2 decimal places because it's a z-score, and a p-value of 0.0114. And you will notice that even though we're given a positive test statistic, I don't just see a marker here at positive 2.53, I see one here at negative 2.53, and both of those tails are shaded in, and that has to do with the fact that this could be different in either direction. If I'm interested in equal versus not equal could mean I'm down here or I'm up here. Either side would make me different from the claimed value, and so we check both tails, and that doubles the p-value. We know to make our decision, I'm then going to compare that p-value to my level of significance alpha. And 0.0114 is less than 0.05, so we will reject our null hypothesis. Since we are rejecting the null, which was the claim that 48.8% own stock, we do have evidence to support that the survey is not accurate. As a statistician, because that test score is on the high end, my sample is above that 48.8%, I suspect the average might be higher, but I didn't check that for sure. All I know is that our evidence is suggesting that the proportion of families who own stock is different from 48.8%. I can't conclusively state which direction with this type of test. All right, let's try one more. The next one says Toastmasters International cites a report by Gallup poll that 40% of Americans fear public speaking. A student believes that less than 40% of students at their school fear public speaking. The student randomly surveys 361 schoolmates and finds that 135 report they fear public speaking. Conduct a hypothesis test to determine if the percent at their school is less than 40%. So this one is nice and explicit. They tell us, conduct a hypothesis test. We liked it when questions are direct. However, they don't give me a significance level. And this is a situation we haven't encountered before. they're not giving us a significance level, we're going to assume 0.05. Sort of like 95% was the default for confidence intervals, 5% or 0.05 is the default for significance levels. Working through that problem, I see that the claim is 40% fear public speaking. Student believes less than 40%, so that's going to give me information about my alternative. Student randomly surveys 316 and finds that 135 report they fear public speaking. So let's go ahead and start our process. We're looking at the proportion, and this test came from data about students at this researcher's school. So our proportion is proportion of students who fear public speaking. We know that our claimed proportion is 40%, so 0.4. We know that our sample size is 361. Our sample successes is 135. And we know that we want to test a claim about less than. So when we come to write our hypotheses, claims about P, claimed value is 0.4. Null is always equal. Our claim is less than. In order to do the test, I should check that I meet that condition. So P times N is much bigger than 5, and Q times N would then also be bigger than 5. So we meet the condition to perform a one proportion z-test. So for the one proportion z-test, I'm going to set up my z curve, and then I'm going to fill out my information for the calculator. We know from the last problem they're going to ask us for claimed proportion, sample successes, sample size, and our alternative hypothesis. So claimed proportion is 40%. We had 135 successes out of 361 sampled, and we are testing a claim about less than. And when we run this in our calculator, it should spit out a test statistic and a p-value. Oops, one more. So I get a test statistic of negative 1.009 would round up to 1, and a p-value of 0.1563. If I were to mark this in the graph, negative 1 is right here, and I'm just a little bit past that. So my test statistic is sitting here. And it's a left tail question because we're looking at less than, so I'm shading that way. And I can see, both from my calculator and my hand-drawn picture, that's a big chunk of the curve, right? That's almost 16% of the data. And that is much bigger than my assumed alpha of 5%. So in this case, my p-value is greater than my alpha. And in that case, we fail to reject the null. Since I am failing to reject the null and failing to reject the statement that the proportion is 40%, I do not have enough evidence to support the claim that the percent at her school is less than 40%. Getting this number of sample successes out of that sample size at her school is a perfectly reasonable value within about 1 standard deviation of the assumed actual proportion. So this sample does not provide enough evidence for us to reject this statement that the proportion is actually 40%. All right, if you have any questions on what you just saw, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.